Today I'm answering this AQA GCSE Physics Paper 1P from June 22. Question 1. Figure 1 shows a large wind farm off the UK coast. The mean power output of the wind farm is 696 megawatts, which is enough power for 580,000 homes. Calculate the mean power needed for one home. Give your answer in watts. So we take that 696 megawatts and we times it by 10 to the 6 in order to get it to watts. And then to make sure we're just getting the power needed for one home, we divide it by 580,000. Our final answer is 1,200 watts needed for one home. On one day, the demand for the electricity in the UK was 34,000 megawatts. Suggests two reasons why wind power was not able to meet this demand. Wind power is a renewable resource, and as with many renewable resources, it has the disadvantage of being highly unreliable. You will not generate any power if there's no wind. The second point you can really give is there's not actually enough land space to accommodate all the turbines needed to generate enough wind power. Some of the energy from the wind used to rotate a wind turbine is wasted. An engineer oils the mechanical parts of the wind turbine. We explain how oiling would affect the efficiency of the wind turbine. It's worth 3 marks. So first of all, what effect would it have on efficiency? Hopefully it's clear it would increase the efficiency. And why is that? Basically, it would reduce the friction, meaning that less work is done against friction, and therefore the amount of energy usefully transferred would increase. In most homes in the UK, there are many different electrical devices. Explain why people should be encouraged to use energy-efficient electrical devices. If devices are more energy efficient, it means that they waste less energy, which would therefore reduce the overall energy demand. Figure 2 shows a rock found by a student on a beach. To help identify the type of rock, the student took measurements to determine its density. Describe a method the student could use to determine the density of the rock. 6 marks. So here is your density formula triangle. So to calculate density, you use the equation mass divided by volume, which means the measurements the student needs to take is both mass and volume. So the student measures the mass of the rock using a balance. And now we need to find the volume of the rock. We want to use a displacement method because the rock is in a regular shape. I'm going to use a Eureka can. So place it in a Eureka can with water level with spout. Use a measuring cylinder to find the volume of displaced water. And why do we want that? Because that will equal the volume of the rock. The student determined the density of the rock to be 2.55 plus or minus 0.1. What are the maximum and minimum values for the density of the rock? So add that. You want to go up to 2.65 for the maximum and minus 0.10 for the minimum, so that's 2.45. Table 1 gives the density of 5 different types of rock. Which 2 types of rock in Table 1 could be the type of rock the student had? So we need to look at these numbers and see which of these rocks match that. So that would go up to 3 and 2.8, so definitely not basalt. This would go up to 2.5, which falls into the necessary category, so there we go. Flint would go up to 2.7 and down to 2.5, which again falls in the necessary data. Sandstone is too low in density, slate is too high in density, so the answer is chalk and flint. The student only took one set of measurements to determine the density of the rock. Explain why taking the measurements more than once may improve the accuracy of the density value. So when you have several readings, it means that a mean can be calculated and allows anomalies to be identified and therefore discounted. An engineering company has invented pavement tiles that generate electricity as people walk on them. Use the physics equation sheets to answer 3.1 and 3.2. What equation links current, potential difference, and power? PIV. So power is potential difference times current. When a person walks on a tile, a potential difference of 40 volts is induced. The power output is this. Calculate the current. So current is power divided by potential difference. So 4.4 divided by 40, 0.11. What equation links efficiency, total power input and useful power output? Its efficiency equals useful power output over total power input. It's the first one. The tiles are used to power LED lights in the pavement. An LED light has a total power input of 4 watts. The efficiency is 0.85. Calculate the useful power output. So we steal that equation, just write it down in the exam. We know that the efficiency is 0.85. We're being asked for the useful power output, and we know the total power input is 4. To find x, multiply both sides by 4 to get 3.4. A student investigated the insulating properties of different materials. This is the method used. Wrap insulating material around the can. Put a fixed volume of boiling water in the can. Place the lid on top of the can. That's going to prevent heat loss and stop convection currents being set up on top of the can. Measure the time taken for the temperature of the water to decrease by a fixed amount. Repeat steps 1 to 4 using the same thickness of different insulating materials. So we've got a good control variable because it's the same thickness. We're changing our type of material, which means that's our independent variable. And we're measuring the time taken, which therefore is the dependent variable. Identify the independent variable and the dependent variable. So type of insulating material. What you're measuring is the time taken for the water to decrease by a fixed amount. The student uses 2 types of thermometer to measure the temperature. What is the resolution of thermometer B? To the nearest 0.1 of a degree Celsius. Thermometer A is more likely to be misread. Give 1 reason why. Remember that the viewing angle will affect the measurement that you take. You can call that parallax error if you're feeling fancy. This comes up a lot in chemistry too. For one type of insulating material, the temperature of the water decreased from this to this. The energy transferred was this. The specific heat capacity was this. Calculate the mass of water. So we use E equals mc delta T. The energy transferred, we've been told, is 10.5 kJ. Get that into joules by timesing by 1,000. We're after mass. The specific heat capacity is 4,200. The temperature difference is the difference between these two numbers, 20 degrees. Sort out your right-hand side, please. So do 4,200 times 20, and then divide both sides by 84,000 to find m. 0.125 kg is your final answer. Table 2 shows the results for two insulating materials. Explain how the results in Table 2 can be used to compare the thermal conductivity of the two materials. So if we have a look, this is the time taken for the temperature to decrease by 20 degrees. So X took far less time compared with Y. So X is a much better thermal conductor, and that's because the rate of energy transfer is higher. A student rubbed a plastic rod with a cloth. The rod became negatively charged. The cloth became positively charged. Explain why the cloth became positively charged. So this is all to do with static electricity. We start by saying there is a transfer of electrons. Remember, they are negatively charged, so make sure you get it the right way around. From the cloth to the rod, electrons are negatively charged. The cloth now has more positive charges than negative charges. Figure 6 shows the negatively charged rod on a balance. Figure 7 shows another charged rod being held stationary above the rod on the balance. The rods do not touch each other. Explain why the reading on the balance increases. So this new rod is also negatively charged, and when you have two negatively charged objects, they repel. So in effect, this creates an additional downward force on the balance, which increases the reading. The balance had a zero error. The zero error is not important in this experiment. Give the reason why. Because we're only interested in the change in the reading, so it doesn't matter if the original reading for that first rod is actually a little bit incorrect. A negatively charged rod is held near an earth conductor. Explain why spark jumps between the negatively charged rod and the earth conductor. What happens here is there's a large difference in the potential difference between these two objects, and therefore the electrons that are built up on the negatively charged rod in effect want to earth themselves, so they jump from the rod to the conductor, which creates a spark, or you can feel it as a small electric shock. Figure 8 shows how electricity is supplied to consumers by the national grid. Explain why transformer X is used in the national grid. Oh, right, so that transformer is present between the power station and the overhead transmission cables. So what that transformer does is it's a step-up transformer which increases the voltage. Now, why would we want to do that? Because by increasing the voltage or potential difference, we reduce the current, which means we have less of a heating effect. So there's reduced transfer of thermal energy to the surroundings, meaning less energy is wasted, and there's a greater efficiency of power transmission. Explain why transformer Y is used in the national grid. Transformer Y brings down that voltage or potential difference to a safe level so it can be used by our consumers in their homes. The town of Hornsdale in Australia has electricity supplied by a huge battery. On one day, the battery transferred this many joules of energy. The potential difference is 230 volts. Calculate the charge flow. Give your answer to 3 sig fig. The equation we need is EVQ. Don't worry about rearranging if you don't want to. The energy transferred is 3.24 times 10 to the 11. We know the potential difference is 230. Times it by Q, which is what we're after. Divide both sides by 230 to find charge. We want our answer to 3 significant figures. You can give that in standard form or just write it out. Alpha particles, beta particles, and gamma rays are types of nuclear radiation. What does an alpha particle consist of? Well, it is a helium nucleus. Use your periodic table. It's made up of 2 protons and 2 neutrons. You could also got the mark for saying it's a helium nucleus. A krypton nucleus decays into a rubidium nucleus by emitting a beta particle. Complete the nuclear equation. Right, so in beta decay, what happens is a neutron turns into a proton, which means the mass number is unchanged because they both have a mass of 1. But we gain a proton, which means the atomic number goes up by 1. Internal contamination of the human body means radioactive material is inside the human body. Explain how the risk from internal contamination is different to the risk from external irradiation by a source of alpha radiation. Right, alpha is a lot more dangerous inside the body because it's extremely ionizing, which means it causes cell mutation and cancer. It's a lot less dangerous outside of the body simply because it's not very penetrating and will be unable to penetrate through the skin. So alpha is very dangerous. Inside the body because it's very ionizing. And causes cell mutation and cancer. Outside of the body, alpha is low risk because it has a low penetrating ability and is unable to pass through skin. Internally, alpha is absorbed by living tissue. A student determined the specific latent heat of vaporization of water. Here's the equipment used. This is the method. Put 50 centimeters cubed of water in a beaker. Measure the mass of the beaker and water. Use the heater to boil the water and keep it boiling for 600 seconds. Measure the mass of the beaker and water after 600 seconds. What measuring instrument should be used to measure the volume of water? A measuring cylinder. What is the hazard in the student's investigation? So the hazard comes from the boiling water because if it touches skin, it will cause burns. The initial mass of the water was this. The final mass was this. The energy transferred was 25,200. Calculate the specific latent heat of vaporization, give a unit. So here is our equation. We're being asked to find the specific latent heat of vaporization, which is L. The energy is 25,200. What about the mass? Well, it's the difference between these two numbers. So to find L, we do 25,200 divided by that answer. In terms of the unit, let's just rearrange this equation. Energy is given in joules, mass is in kg, so actually It looks like this, our final answer. Some thermal energy was transferred to the surroundings while the water was being heated. Explain how this affected the student's value for the specific latent heat of vaporization of water. Now, the specific latent heat of vaporization is all to do with the quantity of energy needed to change the state. Now, because we've lost thermal energy to the surroundings, it means that this number that we've just calculated up here is too high. Some of the water evaporated before its temperature reached 100 degrees Celsius. Explain how this affected the student's value for the specific latent heat of vaporization of water. Well, if some of the water evaporates, it means that we have a lower volume of water, meaning that the end calculation, when we find that L value, will be lower than it should be. So a smaller mass of water has been heated, meaning that the student's calculated value of L is too low. Figure 10 shows a girl doing an experiment to determine her power output by running to the top of some stairs. The mass of the girl was 60 kg, the height of the stairs was 175 centimetres. The girl ran to the top of the stairs in 1.4 seconds. The gravitational field strength is this. Calculate the power output. That's 5 marks. So we need to use a combination of two equations in order to calculate the power. First of all, we're going to use gravitational potential energy equals mgh to find the energy, which we can then substitute into this formula triangle. We've been told the time value, so it should be easy enough to find the power. So starting with GPE equals mgh. The mass of the girl was 60 kilos. Gravitational field strength is 9.8. Height of the stairs, make sure that's in the standard science unit of 1.75 meters. So that energy is 1029 joules. And then power equals energy transferred over time taken. So we'll take that number we just found, divide it by the time, which was 1.4 seconds, to get 735 watts. The total power output of the girl was greater than the answer to question 9.1, suggests 2 reasons why. So why did she need to put out more power? Well, first of all, energy could be transferred as thermal energy to the surroundings. And secondly, it's not enough that she's just increased her potential energy by going up the stairs. She'll also have had to increase her kinetic energy. A boy took more than 1.4 seconds to run up the same stairs. The power output of the boy was the same as the power output of the girl. What conclusion can be made about the boy's mass? So if it took him longer, but the power output was the same, it must mean that his mass was greater than the girl's. Figure 11 shows a student launching a toy aeroplane. To launch the aeroplane, the student pulls on it to stretch the spring and releases it. Just before the toy aeroplane is released, the spring has an extension of 0.12 meters. Here's the mass, here's the spring constant. Calculate the maximum speed of the toy aeroplane just after it's launched. Give the unit. So you need to use this equation, which states that elastic potential energy is 0.5 times the spring constant K times extension squared. And we'll need to use a second equation, which is that kinetic energy is half mass times speed squared in order to find that final speed that we need. So to get going, we're looking for the elastic potential energy. The spring constant is 50. The extension is 0.12. Put that into your calculator to get 0.36. And now we sub it into kinetic energy is half mass times speed squared. So that's your kinetic energy. The mass is 0.02 kilograms times speed squared. So to find V squared, we do 0.36 divided by 0.01 and then square root. And our final answer is meters per second. Complete the sentence. As the aeroplane moves upwards through the air, there is a decrease in the kinetic energy, so the movement energy of the plane. Give one factor which would increase the distance the toy aeroplane travels horizontally before hitting the ground. So basically, how would we get that aeroplane to travel further? We could increase the extension of the spring. We could wind that spring tighter to give it more elastic potential energy. Figure 12 shows some hair straighteners. Hair straighteners contain heating elements. When the hair straighteners reach normal operating temperature, an LED turns on. Draw the symbol for an LED in the box. So that is a light emitting diode. It looks like this. It's a bit like a play button. And remember, because it emits light, we need these arrows. Figure 13 shows the circuit diagram for the hair straighteners. Each resistor represents a heating element. The power output of the hair straighteners can be changed by closing different switches. Why do the hair straighteners not turn on when only S2 is closed? Well, if we closed S2, we'd have an incomplete circuit because S1 is still open. The hair straighteners have a maximum power output of 120 watts. The energy transferred to the hair straighteners is 3.6 kg. Calculate the time taken for the hair straighteners to reach the normal operating temperature when operating at maximum power. Use the physics equation sheet. So we need to use time is energy divided by power. Be careful with those units. We need it in the standard energy unit of joules. The power we've been told is 120. The answer here is 30 seconds. Figure 14 shows the hair straightener's circuit when switch S1 is closed. Switch S2 and switch S3 are then closed at the same time. Explain what happens to the power output of the power supply. So what happens when you close these switches simultaneously is that the total resistance of the circuit decreases, meaning that the current increases, and that has the effect of increasing the power output.